Welcome. Let's take a look at this example. The Cadet is a popular model of sport utility vehicle known for its relatively high resale value. The buy variant data given below were taken from a sample of 16 cadets, each bought new 2 years ago and each sold used within the past month. For each cadet in the sample, we've listed both the mileage in thousands of miles that the cadet had on its odometer at the time it was sold used, and the price in thousands of dollars at which the cadet was sold used, with the aim of predicting the used selling price from the number of miles driven. We might examine the least squares regression line. So we don't have to find it ourselves, it's given. And least squares regression line, we often just say regression line or the line of best fit. So we don't have to do the scatter plot on our calculators. You can if you would like and check out the video I made on that. But the problem here actually shows me the scatter plot, and they're showing that regression line. It's trying its best to describe the trend of how the mileage affects your selling price. So what I'd like to do is just come over to this picture and actually label these axes with what they represent to make it easier here. So my x-axis is representing the mileage on the Cadet. And then up here, my y-axis is representing the price that that Cadet sold for, so selling price. And then if we average all those X values, if we average the mileage on these 16 cadets, that comes out to be 26.55. So I just averaged those numbers. And so on this graph, the sample mean, that location there is 26.55. So I'm just going to label that. So the average mileage on these 16 cars was 26.55, and it's 1,000 miles. And then the selling price average for these 16 cadets, so the sample mean for the selling price is 28.53. That would be that value. And then we use that information to talk about pairing tendency. So when I have a negative correlation here, so there's a downward trend, most of the data, generally speaking, is in this quadrant and this quadrant. So that's what creates, it's going to put most of our data is in that quadrant and that one relative to my X bar and my Y bar. And then we investigate what's called pairing tendency. So, whoops, so sorry about that. Okay. So let's consider this case. So when we have a negative correlation, a downward trend here, I think of this just informally as opposite pairing, meaning when one variable is high, I expect the other to be low. So when the mileage on your car is high, I expect your selling price to be lower. So we'll take a look at how it's worded here. For these data, mileages that are greater than the mean of the mileages tend to be paired with what selling price is. So I'd like to just label that on this picture. So they start by saying mileages that are greater than the mean. So those mileages would be here because this is the mean. So these mileages are above the mean. So right here, these are mileages above the mean for these 16 cadets. So if your car had mileages that were above the mean, the data is here. And so that would correspond to these values. And those values are below the mean in terms of the selling price that they got for the cadet. So here we have selling price that's below the mean selling price for the cadets. All right, so this is why I call it opposite pairing. So when mileages are above the mean, I expect my selling price to be below the mean for that group of data. Right, so mileage greater than the mean tend to be paired with selling prices that are less than the mean. All right, and then similarly, if we have mileages less than the mean, they would be over here, and they tend to be paired with, here's our data, they tend to be paired with selling prices that are greater than the mean, so above the mean or greater than the mean. All right, so the summary is when we have a negative correlation, opposite pairing to me is my way of saying when one number is high, the other one tends to be low. All right, and then let's address the regression line. So it says, what is the slope of the regression line? So the slope is the coefficient of x. So I'm going to rewrite this here so we don't have to keep scrolling back up. So it's y hat equals 42.71. Just come down here. So y hat is 42.71 minus 0.53 times x. All right. So the slope of that line, the coefficient of the x, which is our value b on our calculator, so 0.53, and it's a negative slope. So what I'm going to do is write that as a fraction, negative 0.53, and we're going to put it over 1 so we can interpret it. So slope is the change in y. That's our change in our selling price over the change in x, and x was the mileage on the car. So according to the regression equation, for an increase of 1,000 miles in mileage, so when you see this sentence and it talks about increase of 1, it's referring to interpreting the slope. So the sentence starts with the denominator, a change in 1. So a change in 1,000 miles on a cadet, there's a corresponding, so my numerator here would represent the change in selling price. It's a negative value, so it's a negative slope. So there is a corresponding, it would be a decrease because it's a negative value, a negative slope, and I would expect it to decrease by 0.53, and that was $1,000. So a decrease of $0.53 thousand. So 0.53 is about half. So half of $1,000 would be $500. So every time you put another 1,000 miles on your cadet, you're expecting your selling price to go down by $500. All right, and then let's do some predicting. So the reason for coming up with this regression line is to also help us make predictions on how much you'll get for your car based on the mileage it has. So it says predict the selling price when the cadet has 25.8 thousand miles on it. So that's your X value, 25.8. So we're going to substitute it into our regression equation that we wrote above. So 42.17 minus 0.53 times that value X. All right, and you can enter it exactly like it's written there into your calculator, and that will come out to be 29.0 for rounding to one decimal place, and those units are $1,000. So this represents on average, if you look at all cars that have 25.8 thousand miles on them, on average, people are getting $29,000 on the sales price. So that's what we predict on average for all of them. And the final question then is, what was the observed used selling price in thousands of dollars when the mileage was 25.8 thousand miles. All right, so let me go up to our graph here. So I'm going to look at the one here with the regression line. All right, so they're talking about X being $25.8 thousand. So that's going to be that point. So let me label that. So that point was from the study, XY. So that's what they saw in their data. So this was the observed value. So for that car that had 25.8 thousand miles on it, if we look at the table, you'll see that that sold for $26.4 thousand. So I'm just going to slide over for a second. So this is what I observed in the data. So in my study, I observed a car that did have 25.8 thousand miles, and it sold for $26.4 thousand. So Y represents the Y value from the sample data. So that's the observed. Right, compared to what we predicted. So if you go to that same X value, so we're staying at the 25.8, what we predict would be that value on the regression line. So this is why we need a different symbol instead of Y, we just call it Y hat. So this was the 25.8 for X. And then what we predicted below was $29.0 thousand. So the car in the data sold for a little bit less than an average car with 25.8 thousand miles on it. All right, there you have it. So that covers everything except me filling in the very last blank there. So at the very bottom, again, the observed selling price. So we'll just fill in that number. So I'll just, again, remind you, though, that that would be Y. So Y is what you observe in your data, and that came out to be $26.4 thousand. Okay, and we are done with that one.